Hello everyone, welcome to our statics solution series. In this question, we were asked to find the magnitude and direction of two forces acting on a link. So let's go briefly over the question. So we have a link at point A, and there are two forces acting on the system. The first one is F1 with a magnitude of 600 newtons, and it is making 30 degrees with the horizontal. And the second force is F2 with a magnitude of 400 newtons and making 45 degrees with the horizontal. And we are asked to find the magnitude and direction of the resultant force. Okay, so as a solution methodology, let's separate the forces to their X and Y resultants. So I'm going to separate, for example, the F1 to its X and Y components. And in order to do that, we need to recall our trigonometry knowledge. So if you want to find the X component of a force, you need to multiply the magnitude with the cosine of that force it is making with the horizontal. And in the same manner, you need to multiply the force with the sine of the angle it's making with the horizontal to find its Y component. So let's go over one by one. For F1, let's separate the force F1 into its X direction first. So we need to multiply F1 600 with cosine 30, as I mentioned earlier. So the result is 520 newtons, and the force, as you feel, its X component is acting on the right side, the right direction. And in the Y direction, in the same manner, we just multiply 600 with the sine of 30 degrees. And the result is 300 newtons. And the force in the Y direction is acting upwards. Consider the same for F2. We need to multiply 400 newtons with the cosine 45. But different from F1, the difference from F1 is the X component is acting in the opposite direction. So F1's X component was acting to the right, and as you feel, F2 is acting to the left. So we just put a left sign in this. And for the Y direction, again, we multiply 400 with the sine 45, and it is in the same direction as the F1's Y component. So in order to find the resultant force, we just need to sum up the forces in the X directions. So F1's X and F2's X will be summed up together. And for the Y component, we're just going to sum up the F1's Y component with the F2's Y component. So in X direction, as we can recall, the forces were acting in the opposite direction. So what we need to do, we need to subtract these from each other. So F1x was 520 newtons and it is acting to the right, while F2x was acting to the left. So we just put a minus sign in here. The resultant force in the X direction is 237 newtons. And in the Y direction, as you may recall, both the forces were acting on the same direction, acting upwards. So we just need to sum them up, and the resultant force's Y component is 583 newtons. So what we were asked to find the magnitude of the resultant force. We have the separate X magnitude and the Y magnitude of the resultant force. So what we need to do is we need to take the square of FRX and FRY, which is the X component of the resultant force and the Y component of the resultant force, and we just take the square root of their summation. Why we are doing this? This is actually coming from the triangle equation. So when we do the calculation, FRX it was 237 newtons. We just squared it up. And the Y component was 583 newtons. We just squared it up. And when you take the square root of their summation, what we get is 629 newtons. just one precaution, no matter what the direction of the FRX and FRY, we always sum them up, and since they are squared, their magnitude is always positive. So keep this in mind. And the last step, we need to find the direction of the forces, of the resultant force. So what does this mean? We need to find the angle the resultant force is making with the horizontal. So let's recall, we know the resultant force magnitude is 629 newtons, and when we multiply that with the cosine of the angle it is making with the horizontal, as you know from the beginning of this question, you will get the x component of the resultant force. That is one of the key shortcuts that you can make when you're finding the angle of the resultant force. So our resultant force magnitude was 629 newtons. We just multiplied it with the cosine of the angle that it is making with the horizontal, and the result will be the x component of the resultant force, which we have found here. So when we get that, the cosine of alpha is 0.377, and when you take the inverse of it, which you can do in your calculator or through online calculators, you will get the alpha value as 67.9, so approximately 68 degrees. So the resultant force is acting upwards with an angle of 68 degrees, and this is the angle that is making with the horizontal. So we were asked to find the magnitude and direction of the resultant force, and here we go. This is the magnitude of the resultant force, and this is the angle, in other words, the direction of the resultant force it is making with the horizontal.